Hello everybody. In this video we are going to talk about stress simulations in Autodesk Fusion 360. So it could be due to structural loads, or it could be because the body cannot move at all, and then there is a thermal stress, there is temperature change. So I'm going to show you both of them in this video. So the first thing you need to do before you do any finite element analysis simulation or FEA simulation is to make sure the geometry is defined, which it is, and then the material is applied, which you can see it is. Next, we're going to go and apply the constraints, the loads, create a mesh, and then solve, okay? So with this geometry and this material applied, I go here, I go to simulations, and you can see a range of different studies that you can do. This is the static stress, which is due to mechanical load. This is the thermal stress that I mentioned. So I'm going to go through these two. And then this thermal study alone, this is just how the temperature changes in steady state, okay? Or how does it go from beginning conditions to steady state. There is modal frequency or vibration analysis. There is buckling. There is nonlinear one. There is shape optimization, dynamic events, and so on. So my goal is to go through several of these during this video and a few of the other videos. So here we go to static stress and we create the study. And there is this some of these videos that you can watch if you want. So here the material is applied, let's say. Now, if your geometry is very complicated and it has some features that are not necessarily needed for a stress calculation, you can go to the simplify option and you can get rid of some of these features or replace them with something else, right? And you see here, you can remove faces, you can remove features, you can replace them with primitive features and so on. And that is going to reduce a lot of time in FEA analysis. So in this case, this is very simple. I don't need to do any of that. So I go and apply the constraint, and there are structural constraint, rigid body connection of one to another, and then bolt connection between two objects. So in this case, I want to make it simple. I go to structural constraint. So here we assume that these two holes are completely constrained by the two objects that are basically passing through them. So allowing all three axes X, Y, Z, they are fixed, and I also apply to this one and I okay that. So you see this lock appears, means these locks means they are not movable. And not only you can apply basically a structural load that creates a stress. Now if you increase the temperature, since the object cannot expand in any direction, that also will cause thermal stress. So here we go with a structural load, and you see you can toggle gravity on or off. So you can put the gravity on or you can get rid of it, and you can also edit that if you want along any axis. So here it is along the z-axis, which is upright, and right now it's off, but if you want you can click and turn it on. There we go. So now the gravity is also on, and there are different types of load that you can do: angular global load, linear global load, and then a structural load, right? And then point mass and so on. So here we go with structural load, and you can have force, pressure, moment bearing load, remote force, hydrostatic pressure, and remote moment. So we just go with force, and we apply it on this top surface. And you can do with normal too, we can do with angle, and you can do with components. So let's say it's along z-axis and it is negative 400 Newton and 0 in other directions, and you can of course change the units here. So let's say that's the force that I have, and it's just a force that is going to cause bending. And if there are contacts between objects, you can add that as well. Here we don't have any contacts. Then we go here under the mesh area, and basically you can turn the mesh visibility on. So here this is going to show you the mesh that is currently considered, and then you can go ahead and modify the mesh. Okay, so this is the mesh that you have right now. And then of course you can go here under manage, and you can change the setting, right? Which are, here is the mesh setting, the model based size, right? So you can change the size of the mesh, scale mesh size per part, right? There are advanced settings here that you can pick, like parabolic elements or linear elements, right? And if you don't know what they mean, just I refer you to my videos under playlist FEA and ANSYS, and that's where I talked about the theory of finite element analysis. And then all the other things for the size of the mesh and so on. Okay, so you can pick all of those. And then you see here, it says remove rigid body modes. This is if your object can freely move, which in this case is not. Then adaptive mesh refinement, okay, which basically keeps refining the mesh until it converges. The result conversion do not change after changing the size of the mesh. And right now by default is none, but let's say here I want to do some refinement. So it keeps reducing the size until it sees that the results are not changing really and the results are converging. So I guess it's a good idea to have that in. And then also, if you want to do local mesh control, you can do that as well. So let's say here, I want to, in this area and maybe in this area, I want to have a little bit finer mesh, right? Because those are areas of stress concentration. And once you do all of that, now your mesh is not up to date anymore. So you have to click on this and right click here and say generate mesh to get an updated mesh. Okay, so you need to update the mesh if you change the setting. And there we go, right? So now you see here there are smaller mesh sizes compared to this area. And then you go under solve, you can click on pre-check. If it's green, means you have all the requirements, which is geometry, which is material, which is mesh, which is constraints, and load. If all of them are good and your pre-check is good, then you can click on solve. So here we go, we click on solve, and it takes a little bit. So here I just call it a stress analysis, right? Static, and then demo, give it some name and let it run. It takes a little bit time here to run, so I'm gonna pause the video, and when it's done, I'm gonna come back to show you how to look at the results. Okay, so the simulation is done, and now you see an actual minimum safety factor, which is 4.88, and that means the design is good because it's quite a bit over 1. And then you can see safety factor targets. So if you have some targets, you can determine them here. So based on that, you can have a green mark or a red mark or something. The formation scale is adjusted. You can have it actual or undeformed or anything, right? And maybe you don't want it to be shown. So this is the deform up. And again, remember that this deformation is not actual, it's scaled. So here, this is the minimum safety factor of 4.881, which is over there. That's the location of it. And then you want to see the stresses. You can see the stresses, right? So 7.06 max megapascal is max 1 mises. And if you want to see any other stress, you can do that. You can change the units. You can change the size of this legend, right? And you can see the displacement. The displacement could be total, could be along any of the axes. Let's say I just want to see Z. And then, of course, you can see the reaction forces, right? So you can see the reaction forces here and here. And then you can see the strain, and you can also see contact forces. So there are, and there is no contact, of course, in this case. There are lots of different types of results that you can see. And here, if you go under results tools, you can see animation. For instance, if you go to displacement, you can animate it, right? And you can have the speed slow, fast, normal. You can change the number of steps, and you can animate it, right? So that's the animation of the displacement, and you can have it 2 ways. So it just goes forward and then comes back. So that's one of the first things that you can do. And then, of course, if you go back here, you can look at the convergence plot. And here it seems like with an extra refinement, it could reach to a level that the result was converged. And so your result is good now. Also, you can look at the legend options. You can look at legend min and max. You can generate a document for reports. You can see preview of that. You can save it, and the format is typically HTML like this. Okay, so here you see some information about the mesh, about the material, about the context, loads, constraints, and so on, different forces, different stresses, and everything, safety factor, and a bunch of different results. Okay, and of course you can save the report too, and you see that the format is HTML, it's not a PDF. So this is for generating reports, changing options of legends, and of course doing the animation. If you have another simulation, you can put them side by side and you can compare them. Under here, this is where you can change the deformation. So as I said, the deformation is scaled, adjusted. If I say actual, you can barely see any displacement here. Look, see, this is the actual thing. And if I animate it even, you see, there is nothing to see because the load is not big here. Okay, so that is the actual deformation. So typically we do an adjusted like this. Now that was too much, so we do a regular adjusted like this. And remember that you can see the meshes, or if you want, you can just not see the meshes. It's up to you. And then you can go here. You can see the min and max. You can hide them. You can create surface or point probe. So let's say I want a point probe and I want to see right here how much is the stress, or right here, right here, right? So you see, as I move my cursor, I should be able to see the stress all over the place. And then there are other things you can do. You can create like a cross section too. So for instance, you go here and then it gives you this plane, and let's say for instance you click there, and then it gives you these options for basically moving this plane, right? So let's say you want to see something like that, and you can do that as well here. Okay, so you can also see a cross section like this. Okay, and once you're done, you can click on finish the result. So here we go, and I'm back, and of course you can always go back and you can change anything that you want. Let's say you can go back and change your load. You just need to click on this and edit that, right? Or you can edit your constraints, or you can edit your mesh. You can edit anything and rerun the whole thing here. Okay, so this is doing it with structural load. And of course, remember that you can always export your study to ANSYS if you want more tools, more powerful tools that ANSYS has. You can always do that as well. Okay, and there are some inspections that you can do, and these are to go back to the results. And the results are, by the way, the only thing we generated was a slide plan, but we can always go back and look at the results. So let's look at now a thermal analysis. So we go here and say I want a new analysis, and this time I want it to be to thermal analysis. Okay, and I got this, and here I can add the load, and this time the load not only could be structural, it could be thermal. Okay, and this is a study number 2. That was study number 1. So I can close the study number 1, go to study number 2, and for study number 2, let me again fix these two like that, and then I'm gonna add loads, thermal. So I'm gonna apply temperature to this face, and I'm gonna make it 100. Okay, so I'm gonna apply high temperature to here, and then I go back and let's say to these surfaces around the object, this one, this one, this one, and this one, even this back. So for those, what can I do? I can use a heat source, I can use radiation, convection, or anything. Let's say I expose them to convection, and the coefficient for convection value, let's just use 0.5. Okay, which is a small, and temperature at the ambient is 20. And then here, these two, you can just put anything else for them. So let's say here we go back, and again, thermal load. And this time we're going to apply it to these two surfaces. And for these two, I can say that you can have radiation, you can have internal heat, and you can have heat source. So if I say heat source, and then I use 0, so assume that no heat is passing through them. Let's see if it allows it. Seems like it doesn't. So we have to make it very, very small thing, right? So something like this. There we go. And now the mesh can be generated, and of course you can run your simulation. You see now the pre-check is green. So let me just run it this time with this big mesh, and you see now if you want study 1 is solved, we're gonna go for study 2, and we're gonna see the results of study 2. Okay, so here the system is shown after simulation, and you see the minimum safety factor is 0.1. So clearly this is not going to work. And you see that even a moderate temperature of 100 degrees, when the part is completely restrained, can be quite a bit traumatic. And you can look at all of those, as well as, of course, the temperature. So in steady state, everything will reach to 100. You can look at the heat flux, right? You can also look at the thermal gradient as well. So in addition to all of those mechanical things that you had, now you also have what? You also have this basically thermal results that you can add. Now, one last thing I wanted to mention, if you go to thermal stress, which we did, and here we look at this study number 3, not only you can apply a structural load, you can also apply thermal load altogether. For instance, I can go ahead and again limit these two surfaces, and I can apply thermal stress. I can pick this surface and go to maybe 60 degrees, right? And then go ahead and do convection this time through all of these other surfaces. So let's go back here. Now I assume one of them is extra, so I picked one extra edge, I guess. There we go. There should be 5, not 6 for that, and then these two. And then put them at convection. Let's say something like 5 this time, or 4. And also I'm gonna turn on structural load, and this time I'm gonna put pressure on the surface, and I'm gonna do something like 50 megapascal. Okay, yeah. So with all of that, and I can even turn on the gravity as well, right? Now I can go ahead and let's just apply some smaller mesh in these areas. And then we're gonna generate mesh, and then we are going to solve again. So you can do all of that together if you want, and you can do combined thermal and mechanical stress all together. And that is very common many times in real life that you have both of them. So this is the result. Clearly the part is going to fail. You see 0.14 is the safety factor minimum, and the part is under a lot of stress. You can see that the maximum stress goes up to 239, and you can see now temperature again that can go all the way up to 60 for everything after steady state. You can see reaction forces, and there are so many other things that you can see here. And by the way, let me show you something. So if here we go with reactions, right, and click on this area, you're gonna see that it shows you the X, the Y, and the Z force, right, as well as the X, Y, and the Z moments. So these are also some useful results that you can use in statics as well. So hopefully this video was useful to you and you learned some basics of how to do structural and thermal analysis, stress analysis in Fusion 360. Thank you so much for your attention. I will see you in the next video.